Good afternoon. We should get started. Questions on 2-3, Venn diagrams? Yep. Okay. Number 9 on page 80, is that right?
Yes.
Make sure I'm in the right spot. Okay. Let's see. I might even have... Okay, here's number 9. Now what I did is I first mimicked the diagram that they had in the book. Where those, and what do those numbers indicate again? Those are just like region numbers, right? So region number 1 up in the left there. Okay. So first of all, what do you have to do first? In parentheses, you got to do B union C. So what's in set B? 2, 3, 6, 7. Union with set C. 4, 5, 6, 7. So then over here, I just did this raw union. Put them all together. I got 2, 3, 4, 5, 6, 7. Okay. Now I have to, what? Remove that from set A. Well, what's set A? 1, 3, 5, 7. So I remove, there is no 2 to remove. I do take out the 3. There's no 4 to remove. I do take out the 5. No 6 to remove. I do remove the 7. What's left? Okay, what did you say about 0?
Yeah, I'm sorry. Actually, it was 11 I meant to ask about, but I said 9 by mistake. So
Oh.
Yeah, sorry.
Okay. So you don't have any question on this one?
No, that one I got figured out, yeah.
Okay. Well, let's look at 11. You said 11, right? Okay. Here's 11. Well, where do A, B, and C all overlap?
7.
So I'm starting with that. And then what are you supposed to remove?
The union of A and B.
Thank you. The intersection of A and B. And the intersection of A and B is 3 and 7, right? So if I start with that and I remove these two, what's left? See, if I remove 7, it's gone. I can't remove 3, but still, am I not empty? And that's why it comes up the empty. I would be careful not to call that 0, though. It's similar to 0, but it's just meaning nothing left in the center. Okay. Other questions? Yes. Number 19. Okay, let's see if I... Yeah, I don't know. We'll see if we can make sense out of this. 19 says, draw a Venn diagram to illustrate this specific specified set. All x such that x is not an element of A, or, which means union, or all x such that x is not an element of B. So what I did is I used cross-hatching, going this way to indicate everything outside of A. So my lines that are heading in this direction are everywhere except in circle A. And then B complement, I use this angle. And that's supposed to be everything outside of B. And then you're supposed to take them together to unite them. So in other words, the answer is all the places there's any shading. And so the only thing that's not shaded is this little, I don't know, oval or whatever that is inside. So the result is everything but that. So when you're doing an intersection, how does that come out in the Venn diagram? That's where the overlap is. When you're doing a union, it's just everywhere there's shading.
So, just so I can think clearly on it, when you're doing x is not an element of A, that's always going to be A prime. Or
A complement?
A complement?
Mm-hmm.
Okay.
Yeah. X is not an element of A is a way of saying how did we define that complement? Everything,
everything
else? Yeah, or everything but. That's another way of saying not in A. Yeah.
Okay. That's
Yes.
why I get confused the part of A is sheeted. Like I had it.
Well, that's because of this part. See, you got to remember, we got two things to think about at the same time. You're right. A complement, there's nothing in A at all when I did that. That was this shape. Okay, this was nice and bare. But when I did B complement, that includes parts of A. In fact, there should be a line here too. So you're right. It's hard to keep track of both at the same time, but that's why part of A is included. Somebody else could be upset that part of B is included too, for the same reason. So you almost have to do one step at a time and believe the results. Otherwise, if you look at this and go, wait a minute, if you try making, I don't know how to put this, but if you try making sense of each, you have to put them together, and sometimes that violates some of the individual parts. Anybody, as long as this is up here, maybe we can keep discussing this if you'd like to. Anything else about that one? Pretty sloppy shading job on there. Is there another one to be done? Looked at? Yes. 21. That one I don't have, so we'll just do it. Okay, 21. Well, let's see, 21. X is such that X is an element of A. And I'm just going to write the little cheat thing below. And means intersection. Parentheses. X is an element of B. And X is an element of C. So, translation. B intersect C is this part, because and always means intersect, and then that's to be intersected with. So here's what the problem is just in bare sets. Yes? Oh, thank you. And then we have to do this. Okay. So, parentheses first. Oh, and are we supposed to do this with a Venn diagram? Yeah. So let me set up some circles here, A, B, C. And then I guess we better have a universal set, so we'll put a rectangle in there. So our universal set is sitting out here. Okay, so starting, let's see, we might have a lot to do here, but that's okay, we'll do our best. First, I gotta figure out what's C complement. Okay, should we shade that? C complement. Okay, there's C complement shaded in. Where does that overlap set B? And what I'll do is for B, I'll just make shading this way. Okay, so A complement shaded one way, B is shaded another way. So far, where do they overlap?
wherever there was crosshatching, right? Okay, now, where does all of that, where does the stuff that, you know, and where are we so far? Are we not in this part, everybody? So far? Now, where does this overlap A? Wouldn't the answer just be in this little, in there? And then that would be the final answer. I don't know, why don't we, I don't know, I'll just take, I don't know how to do this, but I'll just put some red in there or something. I got to think about what to do. Can't remember how to do this on here. Anyway, the answer would be this crazy thing. So that would be the final result. We were started running out of directions to shade, but okay. So we got another one. Good questions. I think you're going to like this today. I always, I don't know if you like solving puzzles, but in fact you can even buy puzzles that work a lot like these. There are even like detective games that fit this. You know, it's almost like, I don't know if you ever played Clue, but you're supposed to put all these things together, and it's like you find out that, I don't know, whoever did it was not in the kitchen. Whoever did it, I don't know, had black shoes on, and you start getting all these clues and putting them together, and it's kind of where everything overlaps. You finally find the real killer, kind of thing. In a way, these are similar. They have the same logic behind them. Here's the title, if I ever get there. You know what? That looks like 21, doesn't it? I just hadn't numbered it. It's a little bit neater than the one I just did too. So, okay. The lesson for today is the number of elements in a set. The number of elements in a set, a problem-solving tool. And you notice there's kind of a Venn diagram on the screen. And let's see, does that make sense to you? Do you recognize anything up there? The circle on the left is called the set of odd numbers. And I think if you look, all the numbers in that oval on the left are odd. And then the one on the right is prime numbers. I don't know if you remember what prime numbers are, but prime numbers you can only divide by themselves in 1. And so 2 is the only even prime. And then there's a bunch of other numbers on the picture that aren't either. You know, like 26 is not prime and it's not odd. And so it's outside. Venn diagrams are a good way to classify things. Anyway, let's, I need to introduce a term to you today. It's called a cardinal number. I don't know if you've ever heard that before, but cardinal number is, I guess you could call it, the count. You know what I need to tell you is what it's not. Let me give you an example of a number that's not cardinal. That team finished in 3rd place. When I use the 3 in that context, they're in 3rd place. That doesn't indicate really any number. It's just kind of, they call that an ordinal number. An order, it tells the order. But a cardinal number tells how many. Okay, so when we talk about the cardinal number of a set, all we mean is how many elements does the set have. So you look at my example on this page. I say that the cardinal number of set A is 4. If you look at set A, you should see that I have 4 elements in that set. What's the cardinal number of set B? 3, right? So this is just simple stuff called counting, but it becomes very important. There is notation for this. This statement right here, you've never seen this before. This is the way you write the cardinal number of set A. N parentheses A. This says the cardinal number of set A is 4. So this is the math way to write this sentence. So we have some new notation. The cardinal number of set A is 4. That little N parentheses A. So let me ask you if this makes sense. What this one down here says is the cardinal number of A intersect B is 2. Well, before we can answer that, what is A intersect B in my example? The set with 7 and 12 in it. And now does this make sense? The cardinal number of that intersection is 2, because in the intersection there are 2 elements. Make sense? Okay. With that in mind, we can do some pretty cool problems. And I'm not exactly sure of the context here. Let's just go to example 1, page 84. Okay, actually, you don't even have to look. You can just look at, I've got it all up here. They actually gave us this picture with a Venn diagram. Now, let me just explain. There are 2 language tests, I guess, for foreign language for people who are not native English speakers. There's the TOEFL. I don't even remember what it stands for. The Test of English Fluency or something like that. And then there's TSE. There's just 2 different kinds. Okay, you notice we have some, now these are not, before when I had numbers in here, those are region numbers. These numbers actually indicate how many. So in other words, this 600 is saying there are 600 people in this part of the diagram, there are 200 people in this part of the diagram, and there are 300 in this section. So now I'm using numbers in a little different way. We're actually using the counts. So, can you tell by looking at this the answer to these questions? If 600, what this is saying is 600 people took this TOEFL test only. What's the total number of registered students? Can you tell by looking at the diagram? How many students altogether are we talking about? 1,100, right? How many students are taking the TSE only? 300, right? How many students are taking the TOEFL only? And what does the 200 indicate? Oh, what's the answer to this one? 600, right? And what is the 200 telling us? 200 people took both, right? Okay, cool. Now, let's do, these are really kind of cool. So we're going to dive into it. This is a problem from the assignment. It's a survey. A whole bunch of these are surveys. At the bottom there, I think you can see the text. It says, in a survey of 100 investors, it was found that 5 owned utilities stock only, 15 of them owned transportation stock only, 70 owned bonds, 13 owned utilities and transportation. You don't have to copy those all down, they're in the book. 23 owned transportation and bonds, 10 owned utilities, stock, and bonds, and 3 owned all. 3 owned all 3 kinds. Now, what I did is, they're talking about utilities, bonds, and transportation. So I decided we have 3 sets here. One circle called U for utilities, one circle B for bonds and 1 circle T for transportation. So I just drew 3 generic circles. Now, to do this effectively, you have to do it upside down, usually. Because the first thing you want to put in this diagram is the part where all of them overlap. Can you see that that's this one down here? 3 owned all 3 kinds. So we're going to begin by putting that in position. You see that? Isn't that the only place where all 3 circles overlap? Now, work your way up. 10 owned utilities and bonds. Where do utilities and bonds overlap? Right there, right? This whole section is utilities and bonds. And it's supposed to have a total of 10 in it. What does that tell us? Doesn't it total 10 now? See, I can't mess with that, and this whole section has to total 10. Oh, cool. Okay, we're starting to piece by piece deduce where everything is. The next one up, 23 own transportation and bonds. So this part right here is supposed to have a total of 23 in it. So what does that tell us? It must be 20 there. Next, 13 owned utilities and transportation. So this part right here is supposed to total 13. Okay. Next, 70 owned bonds. Well, how many are already in the bond circle? $30. So wouldn't that mean, to make it come out to a total of 70, that this part we haven't accounted for yet has to be 40? Okay. 15 owned transportation. That can't be right. Oh, 15 owned transportation only. 15 owned transportation only. So they're telling you 15 is this part out here that has no overlap. That's a little different. Notice I even underlined it. 5 owned utilities only. So that's just flat out telling you that that lonely part out there only has 5. Okay, now there's one thing left we haven't figured out. And that's in the very top line of this thing. It says there were a total of 100 people they asked the questionnaire of. Okay, now why is it important that we total these up? Well, think about it while I'll total them up. 12, 52, 55, 65, 85, 100. Okay, they added up to 100. What if they had added up to, let's say, 90?
There would have been 10 universals.
Then we would have put, exactly. Then we would have stuck 10 out here. Now, in this case, they added up, so that tells me there's none out here. In fact, I might even want to put a 0 there, just to be sure. You're going to find in other problems that total is going to be crucial. Now, I guess I didn't put the questions up there. Look in your book, because they ask you some questions about this. I'm not on the right page. Yeah, the question A is, how many investors owned bonds only? And looking at our diagram, we should be able to tell. 40, right? What's question B? How many investors owned utilities and or transportation? Now, the fact that they put and or, that means it's both together. So how many are in the utilities and transportation circles if you do a union? So in other words, what's the total of all of this? 12, 15, 25, 40, 60? Yeah. Okay. And what's the last question? How many investors own neither bonds nor utilities? How many were outside of the utilities or and the bonds? Not I said that wrong again. Not utilities. It's yeah, bonds are utilities. Isn't it just a 15? And if there had been something else by the 0, we would have had to add. Okay, cool. That's kind of what these are like. Let's take a look at number 8. And in order to do number 8, I should really erase. Actually, this is really kind of a cute problem. It says, we're at a college now, okay? And guess what the registrar's name is? Mr. N. Roll. Mr. N. Roll. That's pretty clever. Good name for a registrar, isn't it? Okay. Yeah. Well, anyway, I thought that was kind of cute. Here again, we have all kinds of facts. And this is about a 9 a.m. class, a 10 a.m. class, and an 11 a.m. class. But because we don't want the numbers to get goofed up, I'm going to call 9 N, 10 T, and 11 E. Because I don't want to... If I put numbers up there, I'm going to have too many numbers up there already. You follow? So N stands for the 9 a.m. class, T stands for the 10, E stands for the 11. Okay, we got all these facts. You probably be careful. You want to do the ones that have the overlap first. And again, it happens to be upside down, doesn't it? Way down the bottom it says 5% have all three. So that tells me to do what? Start there, right? Cool. Coming up, 15% have a 10 and an 11. Well, where's 10 and 11 here? Right here. This section right here is supposed to total 15. So what does that tell you? It's got to be 10 there. So we have a group total. 10% have 9 and 11. Doesn't that tell me this? So this totals 10. And 20% have a 9 and a 10. So now that totals 20. Now, coming up further, 40% have an 11 a.m. class. Currently, how many are in the 11 circle? Yes. And I'm supposed to have 40. So I got to put a 20 in there. 45% have a 10. Currently, what are those total? 30. So I got to have a 15, so it totals 45. And 45% have a 9 a.m. class. 10, 25. Now it totals 45. Okay, we're not done though. We better total those. Watch what, let's see what happens. What happens across the top? We have
35, 50, 55, 60, 70, 90.
I only have 90%. Now, these are percents, so we know this has to total 100, right? Otherwise, somebody's ripped up some ballots. And so doesn't that tell us in this case, it must be 10% of the student body that doesn't have a class at any of those 3 times. Who knows? They might be taking all-night classes. So do you see where that total becomes a factor? All right, these are kind of fun little puzzles to do, aren't they? Let's see. Let's do this one on page 88. Yeah. And let me erase again, just to give us one more. Okay, page 88, there's a survey about music. It says it's about jazz, rock, and classical. So I call jazz J, rock R, classical C. 3 circles again. Generally, these are all going to be about 3 sets. And again, we got to, sure enough, it's upside down. 3 people that were in the survey liked all 3. So once again, we begin here. Then we work our way up. 5 like rock and jazz. Rock and jazz, 5. Well, there's already three in there, so now it totals 5. 13 like classical and rock. 10 liked classical and jazz. 40 liked classical. 23 liked rock. 29 liked jazz. And then it says below, there's a total of 70 students in the survey. Let's see if they add up to 70. 24, 44, 47, 59, 57. I only get 57. Is that what you guys get? So what does that tell you? Of the 70, how many are left that aren't down here yet? 13? And they must be out here. They don't like any one of those 3 kinds of music. Does everybody see where I got that 13? And by the way, you can put that 13 anywhere in the universal set as long as it's outside the 3 circles. Now, let's ask the... well, by the way, we haven't answered the questions yet, even though we got it all solved. What's question A? How many students like classical only? 20, right? Second question, the number of students who like jazz and rock, but not classical. Well, first of all, where's the jazz and rock? Right here, right? But not classical. So now I have to take this and wipe this one off. You see that? Jazz and rock, but not classical. So we're down to 2. Did everybody follow it? Oh, did I add those wrong? Somebody else told, okay, let's just see. 24, 44, 47, 49, 59, 67. Yeah. I thought somebody agreed with me on 57. You are right. So we should only have 3 out there, shouldn't we? Thank you. What was the last question in the book? How many students do not like jazz, rock, or classical? Well, now we have a corrected version of 3, huh? Does that agree with the book? Yeah. Okay. I think we've probably done enough. We'll get started in class, but here's the assignment. And please, this is kind of weird again. First of all, the first part's easy, 1 to 25, the odds. But I really want you to do all the first 5. So in other words, I guess you could say I'm adding what? 2 and 4. So 1 through 5, I wanted you to do all, but after that, just the 25, just do the odds. So why don't you get started on that? I'll let you go early anyway, but let's do some of it. If you want to discuss it with somebody nearby, go ahead.